Let's talk about the bonus for Lab 11. So in Lab 11, we were dealing with counters, and the second part of Lab 11 had you dealing with some solenoid stuff. And that was specifically to design a circuit that made the cylinder extend and retract continuously, back and forth, back and forth, back and forth. So what I've done here for the bonus is I've taken the counter circuit and I've put the back and forth circuit together. So the bonus was all about making the counter count the number of times the cylinder goes back and forth, and after 2 times, shutting the whole thing down. So let's just walk through this circuit and see how it works. Now, I press play, that becomes closed, that energizes. We have a holding circuit that remembers the fact that that became closed. So it remembers that event. So with all that said and done, once that energizes, that closes, this becomes closed, which then will allow this rung to work when it needs to. This will become closed, which will do the same here. And then the other thing that's really important is this becomes closed. Now, when that becomes closed, everything starts. Now, we'll take a look at why everything starts. Now, when the cylinder is home, this is closed. We know that. And it just so happens that because this is a spring return solenoid valve, the cylinder is at home. Because if we don't energize the solenoid in that valve, then the valve is not going to tell the cylinder to move. So we can assume that if the solenoid is not energized, the cylinder is at home. So if the cylinder is at home, then this is closed. So now what happens is this becomes energized. So as soon as that energizes, the cylinder starts to leave, and then what happens is this becomes open. And what we have to do is we have to remember that event. We have to remember that this was closed at some point in time, and to do that, we use a holding circuit. No problem. So we're holding on to that signal to keep this energized, and the reason we need to keep that energized is so that the cylinder continues to extend. Once it extends, it hits limit 2, and that becomes closed. Now, when that closes, what happens? Well, this is where the memory occurs. And this circuit remembers that this has closed. Let's take a look. We know that's closed because a long time ago somebody pressed play. What happens is when this closes, that energizes, this becomes closed, and this remembers the fact that the cylinder has extended. Now, when it does extend, this also energizes. And let's just look down here. This guy is a normally closed contact from that relay. And when that relay energizes, this becomes open. When that opens, it terminates this holding circuit. So we know that this then is going to de-energize. And we know that as soon as that de-energizes, the cylinder starts to retract. And then what happens? Oh, that becomes open. Yeah. So that opens up, and then what happens? This is cool. Now the done bit energizes. Let's talk about the done bit. Now, first of all, we'll go back to this. This rung remembers the event has happened. You know what? If you were to ask that rung, hey, rung, is the event still happening? It would be like, I don't know. All I can tell you is that I have a memory of it occurring. And the event was that the cylinder extended for the first time. So now, as soon as it starts to retract, this becomes open. Why? Because look, that closed, that energized, and that became open. So now when this becomes open, this de-energizes and this closes. Right? It goes back to its normal state. So it is now recording the event of it being done, or specifically it's recording the done event. So the event is that the cylinder went out. When it leaves, that event's done, and it records that. So it counts 1. Okay, let's continue. So we know we're picturing the solenoid. It's on its way back. It just left here. That just went back to its normal state and closed and recorded the 1 count. It's still on its way home. When it gets home, this becomes closed. When that closes, that energizes, which is going to make the cylinder start to extend again. When the cylinder starts to extend, immediately that's going to become open, but we got it covered because we got our holding circuit. The cylinder starts to extend. It keeps extending. When it fully extends, it hits this limit. When that limit closes, now these guys energize again. Let's take a look at what happens here with this memory latching stuff. So when this energizes again, this is going to become closed. Now, this time, when it becomes closed for the second time, what happens is this is already closed because that is the done bit. That's the 1 count. So because that becomes closed, that is now the memory latch, and it's remembering the fact that the cylinder has gone out for a second time. Okay, now we know that when the cylinder does go out, it energizes this, and this then becomes open because it's a normally closed contact, so it becomes open, and then it terminates the holding circuit. Once the termination of the holding circuit occurs, this de-energizes, and because it's a spring return solenoid valve, the spool goes back and it sends the cylinder back. So the cylinder starts to retract. So are you with me here? The cylinder is now retracting for the second time. This guy has been latched, and it's telling us, this memory is telling us that it has extended for the second time. Now, as soon as it starts to retract, that becomes open. And as soon as that becomes open, that de-energizes. So this goes back to its normal state. And this counts one more count of the cylinder going out and starting to come back. It's the done bit. So that event of the cylinder going out for the second time is done. So what happens here is this actually just shuts everything down because we're done. We don't want it to go out anymore. And the way that happens is the contact for this is up here. Oh, look at that. Yeah, it's a normally closed contact. So that actually becomes open, which terminates the holding circuit. It terminates that original signal that was being held from the start button, and that opens this. That then terminates the memory of it going out for the first time. Because that is de-energized, that becomes open, that kills the first count. Now, this also opens, which terminates the memory of it going out for the second time. That becomes de-energized, that opens, and that kills the second count. Now, what happens? Does it go out again? No, it doesn't. Because look, this is open. So when it does get home, yeah, because it's coming home. And when it does get home, that will close. When it closes, this will not energize because that is open. And that's it. You get it? Okay, bye.